class, Dr. Barnes here. So let's take a look at these signals and then let's find their respective Fourier transforms. So here, let's see how we can do it. So here in I, okay, we are given x of n to be equals to e exponent n u of what? N. Okay, basically this signal is very similar, or this sequence is very similar to a exponent n u of what? N. And if you remember from our earlier discussions, okay, when we had this one, we got what? Z over what? Z minus a. And the ROC was Z greater than what? A. Okay, if you can remember this one, please. If you can't, please go to our earlier lectures on this same topic, Z transforms, and then you will be able to find it. Okay. So now, liking that one to this one, then we can see that this signal we are given here, okay, that is E N U of what? N, is expected or supposed to have a Z transform of Z over what? Z minus E, okay, into what? Mod Z greater than what? E. Okay, so basically, this will be the transform for this particular sequence or signal that we have. Okay, so now let's go to the second one. Okay, so in the second one, we are given, what are we given? We are given what? X of n to be equals to minus 1 into n u of what? N. Okay, so if we have a signal like this, then basically, liking it to our earlier knowledge like this one, okay, we can just find it that Z transform, okay, let's say minus 1, okay, n u of what? N. Okay, if it goes through a Z transform, then we're going to have Z, okay, over what? Z plus 1. Okay, Z over Z plus 1. Okay, and then we're going to have an ROC of what? Z, an ROC of Z, which is greater than what? 1. Okay, basically this is what we're going to have in this particular case. Okay, so that is the second one. It's very, very simple. Okay, so now let's go on to the third one. Okay, on to the third one. So let's see how the third one we're going to get over there. So in the third one, okay, we are given x of what? N to be equals to here 0.5, here 0.2 for minus infinity less than n less than 0. Okay, so here for, okay, n greater than or equals to what? 0. So this is the sequence that we are actually given. Okay, so now with respect to this sequence, we can say that our x of n is actually equals to, let's take a look at this signal. Okay, look at this signal. Sorry, please, there is an n here. Okay, and this one also, sorry, there is an n here. Okay, so we can say that 0.5 n, okay, 0.5 n into what? Unit step u of n. So what is the u of n? You can see that the u of n is actually here an interval. It's from minus infinity to what? To something less than 0. Let's say to something like what? 1. Okay, let's say minus infinity to something like 1. Okay, so now here, what it implies is that it will have to go to the negative side of the x-axis. Okay, it will have to go to the negative side of the x-axis. Okay, so the negative side of the x-axis, that's this time reversal, minus n. Okay, and it's also less than 0. So let's say minus what? 1. So this is how best we can represent this particular signal. Okay, plus 0.2 what? N into what? Here we have u of what? N. is what this one means, because n is what greater than or equals to what 0. So then this is how you can what represent it. Please learn how to represent the signals. It's very important. Sometimes question can come in this format and you have to do your own representation in this particular format before you can actually solve it. Okay, so now the solution has got to do with this place. This is where I think you may find some little problem. Okay, so we will just look at it. So where we are right now is that x of what? N is equals to 0.5, okay, exponent n, u of what? Minus n minus 1. All right, here plus what? 0.2 into what? N, u of what? N. So what is the z transform of this particular part? What is the z transform of this particular part? Okay, this part is very similar to what we did before, okay, which was a minus a into what? U minus a exponent n into u minus what? N minus what? 1. Okay, it's very similar to this one. Okay, but we can still look at this one quite separately. So here it is actually like this: a exponent n into what? U minus n minus what? 1. Okay, so if I have this one, then in terms of z transform, okay, this will be equals to what? And this will be equals to summation up to what? Summation from up to minus 1. Up to minus 1 from what? Minus infinity. Okay, and here I'm going to have a exponent what? N. Okay, so this unit step here is giving me my summation limit here. Okay, n is equals to minus infinity and n is what? Minus 1. Okay, because if you should represent this signal on the axis, you're going to have here n is equals to what? 1. N minus 1 means n is equals to 1, but there's a minus here, so you're going to have here like this. You're going to have like this. Okay, and it's going to go to what? Infinity. Which infinity? Minus infinity. Here is minus 1, minus 2, minus 3, and this place is what? U of minus n minus 1. Okay, so it's from minus infinity to what? Minus 1. Okay, so now here this place, and the magnitude too is what? Is 1. The magnitude is 1. Okay, so if the magnitude is 1, then this place will become what? Like this. Okay, so now if this place becomes like this, then what I can say is that, okay, let me actually say that n is equals to minus what? N. Okay, n is equals to minus n. If I say that, then I will change, the limit will be able to change. Okay, then the limit can change into what? N is equals to what? 1, and then what? Infinity. And then here it will be a exponent minus n, and it will be z exponent what? N, which is actually equals to what? Infinity minus 1. Okay, sorry, it's minus 1. Sorry, it will not be minus 1. Sorry, I changed it, so it's what? N is equals to 1. Sorry, n is equals to 1. Sorry. Okay, so n is equals to 1. So here I'm going to have a exponent minus 1, okay, into what? Z, or exponent what? N. Okay, so now here, if I should expand this place, and I have n is equals to 1. If n is equals to 1, what will I get? Okay, if n is equals to 1, definitely I'm going to get what? A exponent minus 1 what? Z. If n is equals to 2, what am I going to get? Okay, in that case, if n is equals to 2, I'm going to get a exponent minus 1, okay, z into what? 2. Okay, plus if a is 3, I'm going to get a exponent minus 1 into what? Z. And here is what? 3. This will go to infinity. Okay, so now let's say that if I'm going to factor out anything, okay, if I should factor out anything, I can say that a minus 1 into z, here will become what? 1. Okay, here will become plus, here will become a minus 1 what? Z. A minus 1 z, that's how it will become. Okay, if you don't understand it, you can just multiply. A minus a times a minus a, which is what? A minus 2. and this place is what? A minus 2. Z exponent 1 times Z exponent 1. Z exponent 1 times Z exponent 1, which will be Z exponent 2. So it's the same. Okay, then here I'll have A minus what? 1 what? Z. And then here will become what? Squared. So if you multiply A exponent minus 1, A exponent minus 1, 2, you get A exponent minus 1. A exponent minus what? 3. Okay, here exponent 1, exponent 2, exponent 3, the same. Okay, so it will continue to what? Infinity. So now here, I'm going to have A exponent minus 1 what? Z is what? It's going to be what? 1 plus what? X plus what? 2x squared. Okay, plus up to what? Infinity. Okay, up to infinity. So now what we can actually get in this particular place is that we can get the summation A exponent minus 1 what? Z into what? 1 plus what? X. Okay, sorry, it's not 1 plus X. Okay, according to binomial expansion, it's 1 minus what? X exponent minus what? 1. Okay, so this is what we're going to get at this particular stage. Okay, so now from here, what we can do is that we can just simplify what? Further. Okay, so if we do that, then our here is all what? X of Z. Our Z transform is what we're looking for. X of what? Z. Our Z transform is what we're looking for. X of Z. Okay, so now here our X of Z is going to what? A exponent minus 1 what? Z. Okay, A exponent minus 1 Z over what? Over 1 minus what? A minus 1 what? Z. Okay, so now what do we do? Okay, let's say we multiply through by what? A. If we multiply through by A, here we'll be left with what? Z. Okay, and then if we multiply through by here, we will have what? A here. Okay, and here, what are we going to have here? We're going to have minus what? Z here. Okay, this is what we actually what? Going to get. Okay, but if I should also multiply through by minus 1, then I'm going to get here to what? Minus Z. And then here is going to be what? Z minus what? E. Okay, so basically this is going to be my answer. And then what is going to be my ROC? Okay, so my ROC basically is going to, this series is going to go to what? Convergence when x is less than what? 1. So when x is what? Less than what? 1. Whenever x is greater than 1, it will not go to convergence when x is less than 1. So here, what is x? X is what? A minus 1 what? Z. Okay, this will be less than what? 1. So basically, I'm going to have Z over what? A is less than what? 1, which actually gives me what? Which actually gives me Z, okay, less than what? A. Okay, so here, because it's ROC, I'll take what? Modulus. Okay, basically, this is where you will get to. Okay, this is where you're going to get to with respect to this particular question. Okay, and then from here, we will apply our knowledge as to where we have got to solve for this particular one. Okay, to solve for this particular one. So now you can see that this one I have, okay, this 0.5 exponent n, okay, exponent n into what? U of what? Minus n minus 1. In terms of Fourier, in terms of Z transform, it's going to be what? Minus Z over what? Over Z minus 0. What? Minus 0.5. And then the ROC will be Z what? Less than what? 0.5. Okay, so basically this is what I'm going to get. So now if this is what I'm going to get, then I think the question is already what? Solved, because the question is already solved, because actually this one in itself is very easy to what? To solve, because this one is going to be what? S over what? Z minus what? 0.2, and the ROC is greater than what? Z more Z is greater than what? 0.2. Okay, so I'll just combine the two, and then I'm going to have what? So now what I can say is that the Z transform of x of n, which is given here, is going to be Z over Z minus 0.2 minus what? Z over Z minus 0.5. And ROC, okay, ROC is going to be mod Z, for the first one, mod Z is greater than 0.2. Mod Z is greater than 0.2. And the second one, this part, mod Z is less than 0.5. Okay, so it's less than, so Z, so my final ROC, okay, is going to be what? So this is what? Mod Z, okay, Z is what? Greater than what? 0.2. So it's greater than 0.2, okay, but it's also less than 0.5, okay, less than 0.5. So this will be my ROC. So you see that it's very, very easy and simple to solve. Okay, now let's go to another one, and then let's see what we can do about the other ones that we have here in these questions. Okay, so now let's see about the next one that we have. We have Ivan. Okay, we have Ivan. Ivan, what are we given? Okay, we are given x of what? N to be equals to what? Delta n minus what? K. Okay, so this one, to be able to yes, delta n minus k. To be able to solve this one, you can refer to the properties of what? Z transforms. You see that the time, is it a time shifting? I think yes. Time shifting property, because this is a time shifting sequence. So the time shifting property, if you apply that one, it will work for this particular this particular example that we have here. And what is the time shifting property? In the time shifting property, we had what? X of what? N minus what? K. Okay, which has a Z transform of what? Z minus what? K into X of Z. Okay, into X of what? Z. So if you refer to the time shifting property, I'm sure you see something like this. So now if you just apply that one to this one, you'll be able to solve this particular question. Okay, so now if we have this delta n minus what? K, then its Z transform is going to be what? Is going to be Z is going to be what? Z minus what? K into what? Into delta of what? N. Okay, into delta of n. Okay, into delta of n. And we know that what is the value for delta of n? The value for delta of n, okay, is an impulse, it's a unit impulse signal which has a value of what? 1. So if it has 1, then here our answer is going to be Z minus what? K. Okay, Z minus K. Alright, so basically that is going to be the solution that we have, that we can give for this particular question. Okay, this particular question, that's the solution that we can give. Okay, but I am sure in the questions that we were given here, it was what? Delta of n minus 4. Okay, delta of n minus 4. In that case, the Z transform here is going to be what? Z, okay, Z minus what? Minus 4. Okay, into delta of what? N, which is equals to what? Z minus what? 4. Okay, okay. So basically, this is how you can solve this one. Let's go to the next question that we have. So, the next question that we have is time shifting. Okay, it's also time shifting. So we have delta of what? X into what? N, which is equals to delta of n plus what? 3. Okay, this is a question that we have. All right. I thought I was filming it, so I didn't know I did it whilst my camera wasn't on. Okay, so I have to redo it again for you to see. Okay, so here we had x of n is equal to delta of n plus k. This is also time shifting. Okay, it's also time shifting. But the other one, you see, it was n minus 4. That one is shifting to the right. here n plus 3 is shifting to the what? To the left, because n is equals to what? Minus 3. Okay, because we equate what is in this bracket to 0 and n equals what? Minus 3. So this is what we have. So now n plus what? 3. Okay, if it passes through this z transform, then I'm going to have z exponent 3 into what? Delta of what? N. But I know that delta of n is a unit impulse signal, which is 1. So here I'll have z exponent what? 3. Okay, so that will be my solution for this particular question. Very easy and simple. So let's see the next question that we have to solve. Okay, so we are also given that we should solve for what? X of what? N, which is equals to x of n, which is equals to here is equals to what? Delta of what? N. Okay, so this is also property. This is I think differentiation in the z domain. You can verify. I think it's the differentiation of the z domain, one of the properties of z transform. So we know that whenever you have nx of what? N, then its z transform is minus z. Okay, we prove this one into d into what? Dz into z of what? K. Into what? No, not z of k, sorry. X of z, okay? Into what? X of z. Sorry, okay. Into x of z, okay? So this is one of the properties also. So applying this one here, then I'm actually going to have n into delta of what? N. Okay, therefore its z transform is going to be what? Is going to be n. No. It's going to be what? Minus z. Okay, it's going to be minus z into what? Delta of what? Minus z into delta of what? Dz. Okay, into what? Here is this delta of z here, this x of z, this x of z here. Okay, that I put here. Okay, what you must know is that this is a unit impulse signal. And unit impulse signal, it always has a z transform of what? 1. The z transform of a unit impulse signal is what? 1. Therefore, this place is going to what? Minus z into what? Delta of what? Delta z, okay, into what? 1, because the unit impulse of its unit step signal, unit impulse signal is 1. Okay, so since the z transform, okay, since the z transform, okay, of this one, z transform of this one is what? 1. Or you can see that the z transform of this one, okay, is what? 1. Okay, and we know that whenever you differentiate 1, you get 0. Okay, so here you're going to have what? Minus z into what? 0, which is going to be what? 0. Okay, so very easily you can solve that one also. Okay, so which other one again have we got to solve? Okay, I think we have VII here. We have to solve for x of what? N, which is equals to what? N delta of what? N minus 2. Okay, so now this is a combination of two properties. Okay, it's time shifting and then also differentiation in the z domain. Okay, so these are two properties that we have to combine. Alright, so now let's see about them. Okay, so let's first take the time shifting aspect. Okay, so if I have the delta of what? N minus 2. If I have delta of n minus 2, okay, then in terms of time shifting, what am I going to get? Okay, I'm going to get what? Z exponent minus what? 2. Okay, I'll get z exponent what? Minus 2 into what? Into x of z. Okay, into x of what? Into x of z. But what is the x of z of this one? Okay, the x of z of this one is actually what? 1, because this place is what? Unit impulse signal. Okay, so that means that I'm going to get what? Z exponent minus 2. Okay, since x of z is equals to what? 1. Okay, because delta of n is a unit impulse what sequence. Okay, all right. So basically that is how it is like. Okay, so I'm going to have, so my final answer for delta of n minus 2, okay, in terms of AZ transform is going to what? Z minus what? 2. Now let me I'm going to introduce this one also to the what? To the differentiation in what? Z domain. What is the differentiation in Z domain? The differentiation in Z domain property states that minus Z into d dz, okay, x of what? Z, okay. Here, this property basically it comes from nx of what? N, okay, nx of n, okay. So now, if I should compare this property to what I have here, what I'm going to get here is going to be here. I will have to put them together, okay. So what I can say is that, you see this one I found, okay, is a Z transform for this one, okay. So I can say that this x minus 2 I found here is a Z transform for this one. So x of Z is equals to what? Minus Z minus what? 2. Okay, so now in that case, I can say that minus Z into d into what? Dz. Here, this place, I'll put what? Z minus 2. Okay, I'll put Z minus 2. So if I do that, if I differentiate this one, Z minus 2, what do I get? Okay, I'll get minus 2 and I'll get minus 3. Okay, so what I'm going to get is that I'm going to get minus Z here. Okay, then I'll get what? Minus 2. And I get Z exponent minus what? 3. Okay, so in the end, I'm going to have what? 2Z, okay, 2Z, okay, and then I'm going to have, so 2Z, and then Z what? Cube, okay, which is going to give me 2 on what? Z squared. So now what I can say is that the Z transform for this one, n delta n minus what? 2. If it goes through a Z transform, then I'm supposed to get 2 over what? Z what? Squared. Okay, so this is how you can solve these questions. See you in the next class.